All right, new problem. So the first thing that we want to do, as always, is read that question first. And, we got to take this seriously, right? Because it says, how many inches remain? So when we think about that, we see one of the key words that we're used to seeing, the word remain, that tells us that we're likely going to have to subtract. Now, everybody, before we continue, our final answer, let's talk about that. What unit is our final answer required to be in? What unit is our target goal? Yeah, inches. Again, no matter what number we get, it won't be correct unless the unit that it belongs with is inches. How many inches remain? So with that, let's take it nice and slow. No matter what we do, we got to make sure that when we mix the units together, that we have the same units when we do that. So here we are. We see that it says a ribbon roll is 120 inches long. Okay. So the roll is 120 inches long. And then it says, after cutting 3 pieces that are 2 feet each, how many inches remain? Okay, sounds good. So we see the piece here that is 2 feet, and it's each of them that are 2 feet. We have 3 pieces. So everybody, I got a quick question before we continue. Is the math that we're going to be doing just this? We're going to take that roll, which is 120 inches, and we're going to subtract 2 feet. Is that the only thing that we have to do to be done? Like, let's say we convert the feet into inches, and then we actually subtract, and we get an answer. Is that all we have to do? No, not at all. Not at all. Because there's some key words that we really want to pay attention to. Again, everybody, we didn't cut just 1 piece. We cut 3 pieces. Yeah, we're cutting 3 pieces, and they're each 2 feet. So we have got to really pay attention to that wording there. And I know that we're dealing with that anxiety of, oh man, I got to calculate quickly so I can beat that timer. I get it. But until we get there, we want to give ourselves that time to really understand what's going on. So everybody, it's not 2 feet that we're trying to subtract. If we take a look right here, how many feet did we actually cut? Yeah, we actually cut 6 feet, because if you have every piece being 2 feet and you cut 3 pieces, that's going to look like this. That's going to look like 2 feet plus 2 feet plus another 2 feet. That is 6 feet that we're cutting. So it's not going to be 2 feet over here. Again, I just removed that from this section here. We're going to be subtracting 6 feet. Now, before we can actually subtract, we've made that big revelation, that big understanding. We've got that down. But what must we do before we can actually subtract here? We've talked about it already, but it's always good to talk about it again. We have to convert. Yeah, we have to convert. So we have 120 inches minus 6 feet. Let's turn the feet into inches. Let me write that down right here. Let's convert. And our conversion is going to be 1 foot equals 12 inches. So because we're going from feet to inches, going from the one with the 1 on the unit to the numbers, what are we doing? Multiplying or dividing? Yeah, multiplying all day. Remember, when you're going to the unit that has anything other than 1, you are going to be multiplying by that number that you see. That's a 12. So for every foot is 12 inches, we're multiplying by 12. Everybody, what is 6 times 12? 6 times 12 is 72. Exactly. So 6 feet is 72 inches. That's the same thing. We've got the conversion done. We already had the 120 in the right units. So now it's just about subtracting. So let's zoom in. Let's finish this up here. We have 120 minus 72. 0 minus 2 can't do that. So we're going to borrow 1. And so now we have 10 minus 2, which is 8. And then we have 11 minus 7, which is 4. So our final answer, my party people, our final answer is going to be 48 inches, which is going to be answer choice A, 48 inches. All right, so next question. So first thing we're going to do, read the question first. So here it's asking, what is the ratio of vegetables to all other cans? Okay, so let's write that down. Again, what the goal is here, we need to orient ourselves around that first. And so here it says vegetables to all other cans. Let's make sure we read that properly. Vegetables to all other cans. Quick question, everyone. Does all other cans include vegetables? If I were to count all other cans, does that include vegetables? No, it does not. This is the point at which you might be saying to yourself, or in the chat box if you're here live, oop, I made a mistake. Yeah, again, common mistakes. So this is just an exercise of making sure we read the problem properly, right? Because if we start focusing on these numbers, it's way too easy to get a number that might appear here, and then you think that you're good. You think that you might have that false sense of confidence, and yeah, I did get you. So again, just a learning moment. You're all good. Let's go ahead here and write all other cans. So my party people, help me out. What number am I going to be writing down here for vegetables? Yeah, for vegetables, when we scan the information that we have here, during a food drive, a school collected 80 cans of soup, 64 cans of vegetables, and 96 cans of fruit. Boom, right there. We've got 64 cans of vegetables, so I'll be writing 64 for vegetables right there. From here, we'll proceed by figuring out what all other cans means. And we see that we're going to have 80 cans. Let me switch over to blue here. One moment. We have 80 cans of soup and 96 cans of fruit. What are we going to do with those two values, everybody? Yeah, simply put, we're just going to add them. Simply put, we're just going to add them. So we'll have 80 plus 96 added together gives us 176. So that's what I'll compare my ratio with over here. We have 64 to 176. And so from here, everybody, what we're now going to do is play that little game of simplification. So to play that game of simplification, everybody, what number, given that we have 64 and 176, both even numbers, what's a number that we could try to chip away at from the get-go? Now, some folks might see 16 as a common factor of both 64 and 176, but if that's not entirely obvious to you, we could try 2 or 4. Either one of those numbers might work. We could even try 8. 8 might work because we know that 8 can go into 64. We just don't know if it can go into 176, and we can check that out. So let's go ahead and do so. I'll go ahead and divide 8 into 176, and that's going to be 2 for 17. Because if we subtract 8 times 2, that's 16. Got 1 left over, drop that 6. 8 goes into 16 twice again. So if I go ahead, everyone, if I go ahead and divide by 8 on both, we end up getting 8 to 22. Everyone, is there any more simplifying that we can do here? Is there any more simplifying? There is. 8 and 22 are both still even, which means we are guaranteed to be able to divide out another 2. Exactly. So once we do that, divide by 2 again, over here, and over there, and we end up getting a final answer here of 4 to 11. And there we are. Boom, answer choice A. The ratio of vegetables to all other cans would be 4 to 11, not 4 to 15. You would get B only if you would have included vegetables with the 176, and you would have ended up getting something to the effect of 240. And then that's what would have simplified to 4 to 15. So let me know if that makes a little more sense before we keep moving forward.